Hello students, this question is taken from test series 3 IN from the subject network from the topic network solution methodology, and it is of 2 mark question and it is common data question for question number 48. The given question having the voltage source, that is V is equal to 36 volt, that is having the voltage source 36 volts and having the following circuit. In this we have to find the value of the Thevenin's equivalent of the network. Thevenin's equivalent of the network, which is nothing but the value of, we have to calculate the value of RTH, R Thevenin's and VTH, that is V Thevenin's across this load resistance. Across the load we have to find the value of RTH and VTH. First we will calculate the value of VTH. So assume this network T network, then we can find the value of T network, convert this T network to pi network, which is having the T network 12, 20 and 6 ohm is the T network, 12, 20, 6 ohm. Convert this T network to the pi network, which is nothing but to convert this pi network, which is like this, to calculate the value of A, which is nothing but the value of here the resistance 12 plus 6 plus 12 into 6 by other resistance 20 ohms. From that we can find the value of A, that is 21.6 ohm. Similarly for B also same thing, the resistance here 20 plus 6 plus 20 into 6 by the other resistance, that is 12 ohm. From that we can find the value of B. From that same thing we can find the value of C. Substitute the values of ABC in the pi network, will get like pi network like this. We know the value of pi network, then we can find the value of, convert this pi network to the T network to pi network. The circuit will becomes like this. Pi network having the parallel resistance, that is 24 ohms. See, these 24 ohms and 72 ohms are in parallel. Convert this parallel to series. We can get the value of parallel, that is 24 into 72 by 24 plus 72. We'll get the value of 18 ohms. So substitute the value of these two parallel resistance, that will get the value of 18 ohms. So apply KCL at the node 1, which is Kirchhoff current law. Apply Kirchhoff current law at the node 1. We'll get the value of, can find the value of VTH. So which is nothing but VTH minus total voltage 36 volts divided by this resistance, that is 18 ohms plus VTH by 36 ohms. From this equal to 0. VTH by 18 minus 36 by 18, which will get the value of 2 plus VTH by 36. From this, after solving this value, we can get the value of VTH as 24 volts. First we calculated the VTH, then we can find the value of RTH, that is R Thevenin's. In order to calculate the value of R Thevenin's, we have to short circuit the voltage source, that is 36 volts. Short circuit the voltage source. The voltage here is 0. We can find the value of RTH. From this we can find the value of RTH, which is here. We have to find the value of RTH having the resistance 12 ohm, 26 and 24 ohms. This 12 ohm resistor and 6 ohm resistor are connected in parallel. So 12 ohms into 6 is connected in parallel. 12 ohms and 6 ohms are connected in parallel, that is series with the resistance 20 ohms. That complete circuit is parallel to 24 ohms. So the value of 12 is parallel to 6 ohms, which is nothing but will get the value of 12 into 6 by 12 plus 6 plus 20 is parallel to 24 ohms. Is nothing but 24 ohms is parallel to the 24 ohms, then we'll get the value of R Thevenin as 12 ohms. We know the VTH, that is 24 volts, and RTH as 12 ohms. Then all load resistance as 12 ohms. In given question, they are given RTH as load resistance is 12 ohms. So we know the value of RTH, that is 12 ohms, and VTH as 24 ohms volt. Then the value is Thevenin's equivalent of the network is 24 volts and 12 ohms, which is option B. In this session, we have studied about how to calculate the Thevenin's equivalent of the network shown above. Thank you.